Hello and welcome to lesson 2 of week 17. In this lesson, we are going to look at decorators in Python. My name is Mildred. In the last lesson, we looked at how to write higher order functions. We understood what higher order functions are. And we say that decorators provide an easy way for calling a higher order function. Let us create our own decorator, and then we're going to look at the inbuilt decorators in Python. We'll create our decorator just like creating a function, and let's say we call this my decorator like this, and this is going to take a function as a parameter. And then we want to create another function. Let's give it a name wrapper, and we want it to print something, and then when it prints something we want to call a function, and then we want to print something after the execution of that function, and then we want to return the function wrapper. This is an example of a decorator that doesn't really do anything. Well, now let's create this function that we want it to call. We create a decorator by creating a function that takes a function as its parameter, and then we create another function within that function that is going to call the function we want to call, but it's going to do something before, do something after, or whatever we want. But when we look at Python inbuilt decorators, we will understand why the concept of decorator. So I want to create a function. Let's say I want to say def say hello, and I just want this to print hello. So this is the function that I want to pass to the my decorator function, and I want this to be printed out. We can do it the old way by saying say hello is equal to my decorator say hello, and then we'll print say hello like this. And when I run this, it's going to print something is happening before the function is called. It's going to print hello, and then something is happening after the function is called, in that order. So this is one way of writing it, but the best way we'll ever write this is not to do this like this, but to use the at my decorator. Once we put this at my decorator at the top of any function, we are wrapping the functionality, or we're wrapping the other function there, and this makes it very easy for us to call higher order functions. And so if I have this add my decorator, I'm going to put that just above the function that I want to work with like this, and then print say hello like this. And now when I call say hello, it's going to be the same thing, but this time we had our code neater. So this is an example of creating a decorator and using a decorator. Most times in Python you're going to be using inbuilt Python decorators. There's several of them. In this lesson we're going to go through maybe 3 of them, and I will let you explore the others. Let's look at the class method. We have the class method, we have the static method, we have the abstract method. For a class method, we define methods that are bound to a particular class but are not tied to any instance of a class. And then we have static methods that we use as utility methods that are not bound to the class or an instance. And we are going to define a class method that receives a class at its first argument. We define a class method like this. So the first thing we want to do is to create a class. Let's say a class person, and this person class has this definition. We want to have name and let's say sex, and then we want to have a method here, and let's say the method is want to use a method called by sex, where we're going to call to get a person by sex. And this method we want to make it a class method here, so put the at class method like this. Once you have a class method above a method, then it is bound to that class but not an instance of the class. So when we have def by sex like this, we want to return, let's say, the class. One thing you want to know is that the class method must take the class as its first parameter. So I use CLS to indicate that this is a class that is taken as its first parameter, the name and the sex. So let's go over this again. You define a class. We want to use the class method decorator, and then the method that has this class method decorator above it takes the class as its first parameter. We want to return the class name. We also want to check if the person is a male or female. This time we use a utility method called static method like this. When we have static method, we just define def is male, and for us to know if it's male, we want to pass in the sex. And what do we want to do next? We want to say return sex is equal to, let's use the full letter male. So let's create an object of the class. Let's say we create something called person1, and we'll say person1 is equal to person, which is the class, and we want to give the name of the person, let's say Mildred, and the sex of Mildred, let's say female. We want to create a person2, and we'll say person2 is going to be person. Now we want to use the class method dot by sex, and we want to see this. Let's put Jane female. So let's print out person1, let's print out person2, and let us also print out if the person is a male or a female. Print person dot is male person1 dot sex. So if all is well, what we've done now is defined two people here. We have the first person created using person Mildred female, person2, we're getting by sex Jane female. This by sex will not make so much sense here, but it's just trying to make you see how we use class and static method without doing any of those further manipulation. But this is not like a real case scenario where you will see it in full use. And then we now want to print out what we have in person1 and person2, and then we want to use the utility method, the static method here is male. So we'll say person dot is male. We want to check person1 dot sex to see if this person1 is male. So if all is well, this should print out to the page. So we have the first two is not printed out because person1 is person as object. It gives us the object reference, but it gives us false here because person1 is male is false because person1 is female. So printing this out, person1 dot sex, person1 is an object, but we can make sure we say person1 dot sex like this and person2 dot sex, so we don't print out this object's address. Save, clear, and then we run. So we have person1 dot sex is female, 2 is female. Then we want to ask if person1 is male, false. So this is an example. It might not really make so much sense of an example, but we get the idea of what a class method is, what a static method is. We also have something we call an abstract method. And abstract methods are declared inside of an abstract class without any method definition. It's like a blueprint for other classes, and it allows you to create a set of methods that must be created within the child class that is built from the abstract class. So let's say we are building this blueprint and we're going to have a third party that is going to provide the implementation. That is where abstract classes come in handy. But in Python, you just don't describe or define abstract classes. Python has the ABC module, which we call the abstract base classes module, that provide the base for defining abstract classes. And so let's delete this and try to see if we can get an example of abstract classes. Now, because we need to import from that module, we'll write from, and the module is ABC, import ABC, and import abstract method. So these are the imports that we need to have before we can use abstract method. Let's try to say we are going to create an abstract method for a school. I think that would be a best example to use. Let's say class school, and this school, in the parentheses we put ABC. ABC stands for abstract based classes. Now, the methods we are going to create here are abstract method. We'll say let's use get school ID, and we'll pass get school name. Why do we use pass? So that we don't have an error out, but we do not want to create an implementation for this yet. So instead of get school ID, pass, let's do something like grade. So somebody defines the grades in the school, and somebody defines the homeroom for the grades. So let's make it simpler. We now have a class student that inherits the school, and we will say there in it, so self.grade is grade, self.homeroom is homeroom. What we are doing now is that this class student is going to provide the implementation of the grade and the homeroom, and the first class school is the base class that provides like a blueprint. And this is how we use, or the reason we use abstract methods like that. So it's the same thing with the concept of classes, only that some of these definitions are done by a third party and not by the class itself. Okay, so in your assignment 7, where you had hotels and you were creating rooms and guests, that is an example of where abstract methods would have worked, where the class hotel will implement abstract methods and the rooms and all that are going to make the implementation for the methods that the class defined. So let's define the grade now. Let's say dev grade now, self, and what we want to return self.grade. We're going to do that for homeroom, return self.homeroom. Now let's try to print out something. So let me say student1 is equal to student. We have the grade and the homeroom. So let's say we'll print student.grade, we'll print student.homeroom. So this is just a basic implementation. I'll clear and run to see that all is well. So student1.grade. Now the reason we're having this problem is, and I'm glad it happened so that you can see the different ways we can run into trouble and we want to correct. When we call the print statement, we're not supposed to put a parenthesis like this. We're just calling the grade and the homeroom. So take note of that. So I'm very sure that the error is because we say student1.grade and we put a pair of parentheses. We are calling the grade, but we're not supposed to put the parentheses like that. And I'll clear and I'll run, and then we'll have it printed out to the page. So take note of some of these errors, because they are errors you will likely make, and debugging them becomes easier when you have seen them before. So if we have a child class that inherits an abstract class and does not provide the implementation for the abstract class or for the abstract method, then that class will also be considered an abstract class. So object creation for such child classes is also not possible. So even if we try to create an object, an error is going to be shown. So I want you to read more about abstract methods, class methods, static methods, so that you can understand when they are used. We are going to use a lot of these in our software development project. We have other inbuilt Python decorator. We have at exit.register. Let's do that. That's an interesting one. Maybe when we are dealing with files and when you need to close things, we have at exit.register. It is written like this, at exit.register. So, but before you can use this, we have to import at exit. What this decorator does is that it performs a cleanup task before a program exits. And let's say, for instance, close open files or database connection, release resources and things like that. So if you have this, let's put something and say dev. I want to say dev exit handler like this. So you put my application is ending, something like that, and then you can put, let's print out something. This is the last line of the program, something like this. So once you have this, the code between this exit handler is something that we're not going to discuss, but we're just giving you an example of the decorator that we can use to handle cleanup tasks before a program exits. And so when I run this, we have the last line of the program printed out. And then when the last line of the program is printed, it prints out my application is ending. So the exit handler here is where you put in whatever you want to clean up at the time that the program exits. There are several ways we can do the same thing, but there are ways that are more optimal than others. We have another Python decorator that is inbuilt that we say helps us to make getters and setters. We use the add property like this, and you see a lot of this also. And why I like this is that we can define getters and setters in a better and neater way than we are used to doing. Like when we define a method and want to say method to get age, to set age, those kind of methods, you don't want to do that. You want something better where you can define the property and then define the setter and the data using exactly the same function name or method name. So let's try this. Let's use a school example. For instance, I think the school example makes it easier. So we'll do class school and let's do the def init. And what we want here is just the name, self and name. Let's say self name like this. And let's say that self.name is equal to name. I don't want to define student. But for this name, I'll put self._name like this. Now we've defined the class. I want to use the add property here, and what I want to do with this is to get the values. Using add property, I want to define name and to get the name I will say this. But before I get here, let me print out something so that we can use it along the way. Print getting the name. We have a getter already. So the name of the method is name. So we'll say add name.setter, and what this will do is what we use to set the name. So we'll say dev name self, and we want to give it a value, but I'll just put it in name here since name is what we are using. So I'll say setting the name to plus name like this, and then I'll say self._name is equal to name. Now let's say we want to set something that deletes, like a name.deleter, and we want to get dev name self. We want to print deleting name and delete self.name like that. So we have something basic here to show us how to use the property decorator to do a getter. At property we'll get at name.setter, and this name here is because name is the what we define this as. Then at name.deleter if we want to get something to delete. And so let's try to see this in action. Let me say I want to say s is equal to school MIT, and then I want to do print s.name, and then let me set s now. s.name is equal to Harvard, print s.name. So I have two examples. I'm setting the name of the school to MIT, then I print it, then I reset that name to Harvard, and then I print it. Let's see if we want to delete s.name. So let's run. So getting name MIT, setting name to Harvard, getting name Harvard, deleting name. So this is how we do a setter and a getter using that property. This is one of the most beautiful parts of it, and this is one of the decorators I love the most. We have other things like context manager, and we're going to look at that in part 3. So this lesson concludes part 2 of this course. In the next lesson, we're going to go deeper at tying up all of the professional things that we need to know before we start developing our system. Thank you, and see you in the next lesson.